Okay, good morning, maybe good afternoon, depending where you are. Welcome to this BICSI South Pacific presentation on S008 and S009. My name is Craig Buckingham. I'm just going to do the introduction to the platform here, so we're all familiar with how it's going to work, and then I'm going to hand over to Paul Stafus, and then Murray Teale is going to take over after that. You should on your screens be able to see a control panel. You'll notice there is a chat window and also a questions window. By all means, drop a chat in there just to say hello or whatever. Please keep in mind that this is a public forum, so just watch whatever you put in there and consider that other people will see that. If you have a question pertaining to the subject today, please feel free to drop it in the questions. I will butt in as and when relevant, if it is relevant to what Murray's talking about at that time, and ask on your behalf if he hasn't seen it. Failing that, I will let them stack up to the very end of the session and we'll ask them at that point there. If you have any technical issues or anything like this, make a chat window to me separately. If it's something to do with audio or visual, then I can guarantee it's something on your end, it's not the platform. So you'll have to go away and check those settings on our behalf. This session will be available after the session finishes today, some hours after it finishes. Paul will deal with that separately. So that's it for me. You're not going to see from me again. You will hear from me later on towards the back end of the presentation. So at that point, thank you very much for joining us today. It's a very critical topic. I hope you get lots out of it. And I'm going to hand over to you, Paul. So thank you very much.
Thank you very much for that, Craig. And thank you also to R&M for facilitating this platform for this webinar this morning or this afternoon, depending on where you are in the world. We are aware that we have many attendees. This is a much larger webinar than we have run in the past. So we're very pleased to see that the industry is keen to find out more about these significant changes. Just a little bit of background on our webinar series. We run them every 2 weeks. The focus that BICSI South Pacific has is on empowering us as individuals, as professionals, to do our jobs better. So whether that's giving us an education on technical issues, on regulatory issues, even on legal issues, safety issues, etc. So we're covering a wide range of topics. And for those of you who have joined us for the first time, we certainly welcome you, and we're sure you'll get a lot of information from this. As Craig mentioned a little earlier, this is a very important topic. This has been in the process for a couple of years. We're capturing a lot of significant changes within industry, not just within the cabling industry, but going broader into the application side of things, whether it's digital technologies or building technologies or whatever the case is. So the basis of this presentation, Murray Teale is the chair of the WC80 committee, the committee who put together these updates for both the S009 and S008 regulatory frameworks. We thought it was important that we share this information to as wide a group as possible, because they do introduce significant changes. And importantly, there are risks associated with some of these changes. And it's not just about the cabling world migrating in a particular direction, it's the applications that are moving and drawing us into this particular area. So these changes are really inescapable for us if we're involved with that. Now, I understand a number of you are cablers, a number of you are designers, a number of you are end users, a number of you are suppliers. So we had a wide range of individuals who are chiming in to this webinar today. We're very confident that you'll gain a lot of information from it, whether affecting you in whatever way you're involved within industry. Importantly, take some of the material with you that you can then share with your customers, clients, colleagues, suppliers, whatever the case is, because this is about empowering our industry to know more about what the facts are. Not hearsay, these are the facts, and that's why we have Murray Teale as the chair of the committee to present this material. As Craig also mentioned, just as a reminder, we are recording this webinar today, and it will be available on the BICSI website hopefully early next week. We'll get it up there as soon as possible, and we'll let everyone know that it is available. So if you miss a couple of points, you'll be able to capture it, or if you've got colleagues or clients that you wanted to convey this information onto, by all means, feel free to do so. So with that, I'll hand over to Murray Teale. Murray is the technical director of VTI Services, providing a lot of support and infrastructure services to the ICT infrastructure industry, and also the chair of the WC80 committee and the CT001 committee, specifically relating to cabling criteria. Murray, please lead us in the discussion on these changes to the important S008 and S009 regulations.
Thank you very much, Paul. Great to be here, guys. We've got a little bit to get through today. What I thought I'd start off with is the changes we made are reasonably small, but they're generational. And part of that is just picking up some new technology, some new power considerations. And what we've done is basically changed long-standing requirements in the standard and reallocated them to a new technology, a new way of issuing around the issue of power. I thought I'd start off by saying S008 and S009 are mandatory safety standards. I'll say that again. These are mandatory safety standards. These are standards that are enforced by the Act, but covered by the Telecommunications Act in 1997. These provide us a way of establishing a framework for health and safety, fitness for purpose, and basically make sure that our duty of care obligations are met. Cablers and consultants and engineers are all subject matter experts. You guys are expected to know this stuff. And what's happened is we've actually changed some of the basis for this to happen. So we've got to actually look at this. So the major consideration for us is the new power classification, new energy source classification. This is basically taking what we've done for a long time, ELV, SELV, LV telecommunications, and replace it with a change of technology, a change of ideas about how we view power and how we view safety associated with that. So the drivers of change, as I mentioned, we've got new technology. It's being driven by changes in the world of IoT, but we've now got 3 new energy sources. This is ES1, ES2, and ES3. I'll say that again. That's ES1, ES2, and ES3. Now, ES1 and ES2 is relatively safe. ES3 is hazardous. So ES3 is a hazardous energy source, and it's not that new, but certainly we are starting to see more power being delivered over telecommunications cabling, and we have a hazardous service running over telecommunications. This means your duty of care has changed somewhat, and you really need to look at how you're delivering things safely. So we had a standard that we worked with for a long period of time called 60950. That was a standard that dealt with electronic safety, so the equipment safety, and that's been replaced by 62368.1. So that change in standard has prompted us to actually go through a fairly fundamental change within S008 and S009. We have a couple of other drivers to change. IoT. So the emergence of IoT really means that we're starting to look at delivering technologies different ways. Now, one of the benefits that copper cabling has, it has the ability to deliver power and communications over the same cabling system. So we can get cabling going to a device. It can be provide power and communications effectively to more and more stuff. So when we reviewed the standard, we actually had to look at that consideration, look for that we're going to change the way that we deliver services, and we certainly had to make sure that one pair was in place. We have a published standard. IEEE 802.3 CG is a 1-pair deployment, 1 pair going 1 kilometre and delivering power. So Poodle is a PoE over for single pair Ethernet. This technology is being, certainly the CG is being discussed. PoE is certainly here. We're seeing other things done with power delivery, like pulse power, to get us more power to devices. We're looking at addressing hazardous energy sources on ES3 cabling. So we've had hazardous services being delivered before. So something like a PA system, an EWI systems, that would be hazardous to touch. But now we've got generic cabling, and it's also capable of doing it. So RFTC and RFTV, something like GFAST, will also be an ES3 circuit, or can be ES3 circuits. We're also delivering more power than comms cables. So we have got some products out there that can deliver 1,000 to 2,000 watts of power to a kilometre. Certainly that's not over standard structured cabling. There's a product called Volt Server, you're interested in digital power. But if we just look at PoE, we are now looking at heat rise as an issue. Now, the problem with heat rise is that as the cable heats up, it gets to past its operational temperature, and then the pairs change within the cable. And what we find then is when it cools down, the cables are no longer functioning. We also looked at this revision of standards about fire propagation and fire handling. There was a lot of work done, and we reached out to the Building Code of Australia and asked them for their position. We engaged with Fire Protection Association, and we've looked at very seriously at the issue of fire and fire propagation and fire handling within the standards. We had to address modular plug terminated links. This is a link that we put a plug on the end of a cable to plug straight into something like a camera or a WAP. There has been a number of issues where these failures have caused harm, or in one case death. So we as a organisation looked at actually making sure that we had some dependencies on this, and we tied a fit for purpose clause within S008 and S009 for these modular plug terminated links. On the other side, the 1101 series of standards done through Standards Australia also came up with a test method for doing this. So we have now got a test method that is capable of testing these modular plug terminated links. We had a look at laser safety labelling. This has been a mandated requirement for cablers to actually label the installation. I'll say that again, it is a mandatory requirement for cablers to label fibre optic systems as part of their registration, as part of their work. Now, there is other laser safety standards, but that's dependent on you understanding what sort of laser you're using on a site. We as a group needed to address that and come up with a way of ensuring that people got warned of the dangers of lasers in the workplace. There's a general fitness for purpose clause came in. The fitness for purpose clause is really to address the health and safety aspects of the standard. It's a requirement under the terms of reference for S008 and S009 to address health and safety. And roughly translated, that comes into a duty of care. So we need to understand that as we start to rely on technology more for health and safety, that we have not only the standards to address, but we have a duty of care to address to make sure that the systems we're putting in remain operational. So we often talk about health, safety, and service availability. So we started to recognise that assisted living and a whole lot of new technologies are very dependent on technology, and we just need to make sure the platform is in fact fit for purpose. We looked at engineered solutions, and writing a standard, we came up with a very it's nearly one solution solves all problems. However, it is clear that in some cases engineers need to be able to step outside the standard and address this. So we allowed for engineered solutions. I'll talk about that a little bit later on. Engineered solutions are available to people, but they carry a huge risk. And the other thing that we had to address this time round, last time we reviewed the standard, we thought that the NBN was going to be a deployment made over fibre optic cables only. Things changed. So we've now got deployment over twisted pair as well. So some of the considerations about putting hazardous voltages back into the network were discussed, and we basically made sure that we kept the standard going and offered protection for the network. We introduced a couple of changes. We've got ES1, ES2, and ES3. And we've introduced something called ES3 generic cabling and generic cabling. And the reason we needed to do this is because of PoE. PoE is going to cause us to have heat rise in cables. And we needed to come up with a term that indicated that we had something where we were expecting to use something like generic cabling. So this is a patch panel to an outlet with Cat5, Cat6A cable running to it. And we expect it to carry not only data signaling, but now power. And the power that we're doing this is coming up close to 100 watts. So 100 watts, we start putting cables in bundles, we start to get the cables in bundles, we start to get heat rise. So, and if we had our thin conductors or the conductors too thin, then what we would do is we'd discover that we'd get heat rise in the cable, making the cabling non-operation, and in fact, causing harm. We can get, with the thin cables, heat rise above ambience to 70 to 80 degrees above ambient. So the first thing we've introduced is a minimum, a maximum conductor resistance. It's equivalent to about 0.5 mil or 24 AWG. So that's the minimum cable you can use for horizontal from the floor distributor to the TO, from outlet to cabinet is now 0.5. It's expressed as conductor resistance, but that also goes for the backbone cablings. So that also goes along and says the backbone cabling has to be a minimum size. And I'll say again, that's 0.5, not 0.4, but 0.5. So going forward, the minimum cable without engineering involvement is that if you're going to put a backbone cabling in, it's going to need to be 0.5 millimeter. Now, we also introduced the concept of a person type. So this is basically a person type is to give each person an understanding or talk about people with different risk profiles. So the ability of somebody to assess the risk and take the appropriate action. We've looked at upgrading the earthing requirements because, again, PoE sees a lot of external devices, and with a lot of external devices, we're more worried about lightning strikes. So with lightning strikes, we had to provide a earth that is capable of taking that lightning strike. There is some considerations by other standards about performance, but this is a safety standard, and all we're concerned about in this particular thing is it is safe. The only performance requirement we have is that we are going to have something that is fit for purpose. So we need to understand what that means, but typically, if you put a Cat6 cable in or Cat5 cable in, do it 90 meters with the jack at both ends, that's going to be good to run gigabit. If you want to run something that is running 10 gig or 2.5 or 5 gig, then you would need to put in something like 6A to make sure it is fit for purpose. The two standards are published.
Sorry.
The two, yes.
Just back on that last slide there, specifically pertaining to the AWG dimensions of 24. There we go. That, just to clarify, is the permanent link or the CP link effect.
Yeah, that is the link. So it links distributor to distributor, and it also links. It's a permanent link from floor distributor to TO. It covers both the backbone and the horizontal.
So it doesn't preclude these ultra skinny cords and all this kind of.
No, it's we've that's another story for another day. We've not excluded the cords. There is some work being done on looking at what they should do. Some of the skinny cords don't actually make the requirements of 11801, but they're sold in the market. The cords are exempt from. They've got to meet the S008 requirement, and there's some requirements for S008. But skinny cords have their own issues with them about the amount of power they can carry. If we start talking about 500 milliamps per conductor, and you've got 8 conductors in a skinny cable, and you've got them permanently on, and you've got a whole bunch of them in a cabinet, it's going to be an issue. It's not being picked up as a safety issue for us yet, and failure would result in something you could fix up quickly. But if it's mission critical under my duty care, I would certainly, if it's something supporting a camera that had some health and safety aspect to it, I wouldn't particularly use them. But that's my personal.
Well, that leads on to a question that's just coming off the back of that. Is the hypothetical question that what if there is a failure of a life safety system due to skinny cords when it's deployed under an ES3 system?
Well, ES3 special, and we'll talk about ES3 a little bit later on, but ES3 special, you shouldn't have customers moving around ES3. So PoE at the highest level is ES2. So it's only when you start getting at things that is hazardous to touch that you get at the ES3. and we made a beautiful cable to stop doing that, which is, sorry.
So yeah, so then, sorry, just on the ES2, the high PoE levels then, sorry, if somebody's using a skinny cord of that kind of falls outside of this a little bit then.
Well, it's a fit for purpose thing. So the people who the cablers, if the cablers did it, they would be under their fit for purpose clause. For an engineer, it'd be under their duty of care and the professional indemnity aspect to it. And unrelated to this, I'm actually got I've engaged Peter Mayer to actually do me a report on it to see where it sits with compliance to the 11801 series. It's a good point, but we've not addressed it in this group of changes.
Okay, we'll leave it there. Thank you.
Thank you. We've got some. Well, we published S008 and S009 have come into force. So both of those documents have come into force. What we're going to do is we're going to have S008 and S009 running in parallel for a period of time. S009 is going to run into effect for 18 months, and S008 is going to run in effect for 2 years. So basically, you can use either standard over that time. So you can use either version of S009 for 18 months or either version of S008 for 2 years. This is your time, ladies and gentlemen, to actually get your house in order. This is time given to you to say, here is the standard, here are the requirements, you need to understand it, you need to get your head around what those changes are. So let's talk about some content. So we've got ES1, ES2, and ES3. It's derived from a standard called 62368.1, which replaced 60950 for those who are in the standards. That used to be the old equipment safety standard 60950, and it's been replaced. We no longer in S009, the current version has SELV, ELV, LV, limited current circuits, TMV, and LV telecommunications. They're basically being replaced by ES1 and ES2 and ES3. Now, interestingly enough, ES1 and ES2 can be any voltage you like, as long as the current is limited. And ES1 and ES2 can be any voltage as long as the, any current as long as the circuit is voltage limited. So I'll say that again. ES1, ES2 can be any voltage as long as the circuit is current limited. ES1, ES2 can be any current as long as it's voltage limited. So basically, you could have 1,000 volts circuit and it'd still meet ES1 requirements if your current was very, very low. ES3 has no current or limits restrictions. So there is absolutely no current or voltage restrictions on ES3. So that becomes quite interesting. ES3 is deemed to be hazardous. So ES3 is deemed to be hazardous. So we think about what ES3 may be. A PA speaker or EWIS system speaker can be deemed to be hazardous because it's 100 line volts. We can get basically RFTC and RFTC-B circuits. The carriers we use, some of those would be hazardous. G-fast can be hazardous. So we look at that. That needs a special case, and we are dealing with telecommunications that is hazardous, and we're likely to see more of this hit the market. ES1 and ES2 is deemed to be safe. ES2, you need to have a safeguard in place. So basically an RJ45 is safe because you can't put your finger in and get at the pins. So ES1 and ES2 are deemed to be safe. PoE at the highest level is ES2. So it is good. ES3 generic cabling, so this is when it's an RJ45 at one end and an RJ45 the other, or presents as an RJ45 typical generic cabling. That cabling has to be Homebush red. Sorry, Homebush gold with Homebush red writing. So it's a gold cable with red writing. I don't believe you can buy any at the moment, and I think that's a really good idea. If you're going to use this cable, it is going to be hazardous to people, and we've got to be clear. The electrical workers are concerned about it because they understand that this cable will be hazardous. It is outside of electrical regulation at the moment as part of the AS3000 licensing, but it may be pulled up under our health and safety. So ES3 cabling again is Homebush gold with red writing. So this is a cable that we're going to put around and actually attempt to use it for some service. I would imagine it's remote power feeding for DSLAMs and the like in customer premises. We have ES3 application-specific cabling, and that's the new code for LV telecommunications. So your PA cables and your EWIS services.
Sorry, Murray, just a clarification again there, please, on ES2.
Certainly. I like you breaking up, otherwise I just feel like I'm talking to myself.
No, that's all right, mate. I'll keep you in sanity check. ES2 is deemed safe with safeguards, brackets RJ45 style outlets. Examples of that for the listeners, please?
Well, in fact, the safeguard is the RJ45 outlet. You can't get your finger in at the pins of an RJ45, so you can't make contact with the pins of an RJ45, so you can't make contact, so it's deemed to be safe because you can't get your fingers in at the pins. So an RJ45 socket, by its nature, is a safeguard.
Okay, so no shuttered whatever or lock-in things.
No shutters required. It's just just your fingers can't make contact. It does change somewhat for, and we've addressed it in S009 for young children, so preschool, kindergarten type areas, because their fingers are small, they can make actual contact with the circuit. So there we suggesting they put it at a height or form some other form of protection.
Awesome, thank you very much.
Thank you. Guys, generic cabling warning, you need to put a sticker on this or some sort of marking to indicate there's a hazard. It's a hazardous energy source. So this is basically going to be something that says we have a problem with this particular circuit and it is dangerous. It is something that is not excluded under the terms of reference of S008 and S009. I think you'd have to be very careful using this, and I would suggest very strongly that this would be in some form of controlled environment. You don't want to have this where people could actually accidentally gain contact with it. I'm not sure that I'm overly comfortable with a patch cord where I can get my fingers against the contacts carrying a hazardous services that is neither current limited or voltage limited. Obviously the cable will break down if you put too much current down it, and in fact the cabling connection between the jack and the cable is the part that tends to break down. When we did heat rise calculations internationally on the standards to work out what the cables were, we turned it up to point of failure expecting fire, but what we got was the connection at the on the experiments we did between the cable and the connectors to fail.
Hi, Murray, just going to button again. We seem to have stirred up a bit of a hornet's nest on the ES3 thing there. Are you able to see your questions tab so we can address these now?
No, I'm not. I've got them turned off so they don't get distracted. I'm happy to take questions though.
That's all right. So referring to ES3 generic cabling, does this mean 4-pair twisted pair cabling / structured cabling and not figure 8 for speaker cabling?
No, that would be that's ES3 specific application specific cabling.
Thank you. Can you please explain how a 100-volt line is outside the ES3 classification?
It is a 100 line volt is ES3.
Is ES3, okay, there you go. So maybe slip of the tongue, that's fine.
It's not ES3 generic cabling, but it is ES3 application specific cabling.
Roger. Shutters for early childhood and kindergarten are a should and not a shall, brackets mandatory requirement.
I would have to say that I believe that's the case, but I'd have to check on that. I've not got that in there. I know we talk about it quite a lot, but there's a height recommendation. We do warn people of the dangers of it within S009, but I don't have the clause in front of my mind right away. I can come back to you on that.
Yeah, so maybe I'll put that up separately. Last one there. Does the updated standard have a clause to mention that RJ45 sockets are to be protected by parents?
No, there's nothing in there for parents. The only place we talk about it is with the in schools. The technologies in homes we've not actually addressed.
Okay, we'll leave that there for now. Please carry on, Murray. Sorry.
Okay, thank you. This is the separation cable, and it does make life a little bit easier. These are the new 3 classifications for, and I don't know if you can see, let me just put a laser pointer on so it makes a little bit more sense. These are the 3 classifications we have now for power. The 3 here for power. These now, if it's ES1, ES2, and ES3, it means it's telecommunications energy sources. These are power, 240 volt, 450 volts, well, in fact, it's not 220 anymore, 240, but these are electrical supply cables. Separation still remain 50 mil. You notice here that we have to separate ES3 from ES1 and ES2. That's fairly important to note. ES3 is a hazardous cable. We do not want to extend the hazard down ES1 and ES2 cables, so the separations are exactly the same as LV power. So 50 mils or a durable barrier is what we're looking at. Terminations behind it are exactly the same. 150 mil separation required between the terminations. That means you can't have it sitting in the same base plate. You can't have it sitting on a patch panel sitting next to each other, because you won't get 150 mil separation there, or a durable barrier. So this is important to understand. These are the new tables. As I said at the beginning, this is a small change. This is not changing this in any way that what we had previously. It just makes it clearer what we have, and certainly for an ES3 generic cable, which is the first time we've introduced it, you've got to understand that that will need its own pathway, and it would have to have its own separation requirements for both ES1 and ES2 and for power. So ES3 would still need to be separated from LV power. So we've got these classes of people, and we talk about them in the standards now. It's derived from 62368.1. We've got ordinary people, who are just people that are just general population, equipment users or bystanders. We've got instructed people, and this is somebody who's trained or supervised by somebody who's a skilled person, sort of knows the danger they'll be doing, how to identify the dangers to some level and avoid dangers. And a skilled person is somebody who's appropriately trained, qualified, and experienced to determine the risk and manage the appropriate safeguards. Unfortunately, I would say that or fortunately, registered cablers would be deemed a skilled person, because they are registered cablers. They have a full understanding of the requirements of S008 and S009. They're obliged to keep themselves up to date, so they would be somebody that I would deem to be a skilled person working on passive cabling systems, not on active cabling systems, but on passive cabling systems. I would say that they are a skilled person. I think when we start getting into the other areas of active, I don't necessarily know if they would hold the skill level that's capable of addressing all the needs. Remote power, we've got remote power coming. It's basically PoE, 500 milliamps per conductor. That's 1 amp per pair. That's 2 amps going one way, 2 amps going back the other way. If you want to learn about this a little bit more, there's a standard called 4763-2, which is RP1, RP2, and RP3, 3 different classifications for dealing with power on structure cabling. Basically, RP1 is the old Ethernet, so no real problems there, and RP3 is everything's at full power all the time. So when you're doing design, that's probably something you'd like to consider and reach out to your vendor to look at what you're dealing with. About 80 watts is the top range of PoE, 460 milliamps going down the cables on each conductor, typically for that PoE. We get some things like HD-based T that probably a little bit higher. We get heat rise from the bundling, the conductor size, insulation material, coupled with the ambient temperature. So if you start bundling the cables together, you're going to get heat rise. If you're going to start putting smaller conductors in, you're going to get heat rise. If you're going to start putting in insulation, you're going to get heat rise. So all these requirements have been looked at and said we still need the cable to function at the end of it to make sure we're supporting health and safety things. So we've basically said minimum conductor size is 0.5. it's expressed as maximum conductor resistance, and that's the clause you can find it in. We basically need to make sure that the cable keeps on operating. We've got to make sure that it is actually installed and still fit for purpose. So there's a clause, a general clause in both S008 and S009 that says things have to be fit for purpose. Now, fit for purpose is basically indicating that things were going to work as they were intended. It's a requirement of both S008 and S009, and typically if you put a category 5 generic cabling system in, you would expect it to be able to support gigabit Ethernet. If you put a 6A system in, you would expect it to be able to do 2.55 and 5 gig, 2.55 and 10 gig. And it's important to notice that WAPs are often 2.5 and 5 gig. There's nothing stopping you in S009 putting in a cable that is Cat 5 or Cat 6 and for a WAP, but the only expectation of that is it's going to support gigabit. It won't support 2.5 and 5 gig. So it's just a matter of making sure you understand that. Eliminator 1, by the way, says the minimum cable for WAPs is and cameras is 6A. So if you look at Eliminator 1-6, you'll find out that 6A is the minimum for that particular set of cabling. On the modular plug terminated links, all we've got to do is we can put a plug on the end of the cable to go straight into a camera or a WAP. It's quite popular in places like prisons and schools and hospitals where you don't want people getting at the devices. It is a requirement that you keep it out of arm's reach, and we've got a new definition for arm's reach, and it's contained as a fitness for purpose clause. We put in a special note about modular plug terminated links. 1101-1 now contains a test method for it, so you can actually get a test method for it. The other thing about this is probably aimed at more at the engineers. Most of the equipment we put in has a MICE rating. In fact, all the equipment we have is a MICE rating. And most of the equipment you put in the office is MICE 1, which means it's a nice controlled environment. You've got no hard conditions. But Eliminator 1 does specify a MICE table and talks about things you may consider: mechanical, ingress rating, climate rating, and electromagnetic rating. This would certainly fall into a fitness for purpose if you've got a harsh condition. So the question will be asked, is this product fit for purpose? And these are things you can consider. I'm often surprised that people don't know of the existence of Eliminator 1-1. If we look at 4763-2, it talks about the amount of heat we can get into a cable bundle. It's 38 degrees above ambient is in some of their recommendations if you put it in trunking, and it will exceed that if you put it into an insulation. This is 38 degrees plus ambient temperature, and the operation temperature of the cable is 60 degrees. We've only got really 22 of ambient temperature before we start hitting a problem. So this is a fairly important aspect of your understanding about what your cabling is going to do. There is some requirements of 4763-2 will help you out, but installers, I would suggest you speak to your manufacturers, your vendors, about how many cables they will allow you to have in a bundle and what sort of temperature rise you're expecting to get out of that. Modular plug terminated links, we've talked about it recently before. It's got to be out of arm's reach or firmly secured. It's got to be put into a mated, it's got to be mated with a bit of fixed customer equipment, and the plug's got to be suitable. We've certainly seen failures caused from people putting the wrong type of plug on the end. Lots of manufacturers have these that will perform at levels, but the one you go down your local wholesale and buy and crimp on and hope for the best, that's all you're doing is hoping for the best. We've seen some of the most critical links, panic buttons in watch houses for suicide watch, cameras in freezers, protecting life, panic points at universities and railway stations where these things have been installed and failed miserably. We've even seen them put in data centers where people have crimped on their own plugs in a data center in the power and seeing a data center being taken down by use of these particular things. So they're not outlawed. You've just got to make sure that they are fit for purpose. The fit for purpose clause picks these things out as a major event because of problems that people are having in the field to get them to work. We had a look at fire-rated material. We went through and had a look at some of the cables, like nylon jacket burns quite well, lets off a lot of smoke, and we've got this particular issue. We approached the Building Code of Australia and asked them what their requirements were, and they basically said, as long as you stop it at the firewall or the fire penetration, life was good. So we looked at that. We engaged with the Fire Protection Association and basically said, yep, this is what we're doing. And basically, the thing that I would take away from that, if you break it, you fix it. If it's broken, you use it, you fix it. So if you come up with somebody's already made a hole through a fire penetration, you put a cable through it. It's your responsibility to reinstate that to its old fire rating position. I'll say that again. If you come along and find a penetration going through a floor, as an example, you use that cable. It wasn't sealed when you got there. After you put that cable through of yours, then the responsibility falls on you to do fire sealing. You can actually get the building owner to actually put in writing that their fire stopping will be done by others. I think that's a brave move from any builder owner that wants to do that, because they won't necessarily know where all the holes are that contractors have created. Everybody's in the firing line if something happens with that particular area. So this has been fire stopping has been a requirement of the standard for as long as it has been a standard. It's an obligation, and it certainly falls under duty of care. We've got some new requirements for comms pit lids, and basically you've got to provide you some illustrations about what the environment is that they're designed to go into. There's a whole pile of requirements that they're saying we're going to need to actually have these sort of properties covered off, how to make a seal, how to make changes to the product. It is a mandatory requirement now that this is out of S008 that they provide this information, or say particularly they don't. And this is, we need a structural engineer report to say what the test methods were to demonstrate this. So this is an obligation now on the people making communications fixed and access. Oh, yes.
So just back on the fire rating side of things, there was a question about under S008 16.1, would this require the cable to be fire rated or low smoke zero halogen? No,
we don't care if it burns. we do not care that if it burns or not. Otherwise, we couldn't put nylon jacketed cable in. Although I've seen some people claim that to have a nylon jacketed loose tube cable, it would be very difficult to make. And I sometimes wonder if they've actually got low smoke zero halogen down pat. But it's their claim. They're just a matter of they would have to make it there. So at the end of the day, we're going to need to see cables that are particularly fire stop that when we come through the fire penetration. Sorry, I lost my train of thought there for a tick. So nothing too exciting about pits. Probably for the engineers, understand that this is some paperwork that's available now for you to actually make sure you're getting the right pit. So clearly, this is something that people may ask why you put the wrong pit in there or why you didn't check it. Next one is earthing. I like this 2020. 2020 is a new requirement. This is out of S009. It's basically saying we've got to provide a 6 mil earth bar next to a distributor that terminates cabling, copper cabling that comes in, or conductor cabling that comes from outdoors. This is now a minimum requirement for all distributors that carry any cable into the building from outside. This is due because IoT has come, and IoT has a lot of equipment installed outside now. So it's a requirement. Every distributor needs to have an earth bar or terminator on the back mount of the distributor. So this is a 6 millimeter earth. It's a protective earth, not a communication. It's not a TRC. It's a 6 mil protective earth. Laser safety. Laser safety requirements are based on Class 3B lasers being used. The wording's changed slightly. It's a yellow label with black writing on it. There's 2 stickers you need to have. This is not a new requirement, but it's some of the lowest levels of conformance. This is something that is in the standard, and it is mandated on the installer to actually put these labels onto it. Basically, you need to have a label on the outside of the communications cabinet. So you need to have a label on the outside of the communication cable, a cabinet that says the warning label and a little starburst. So when you're coming up to the rack, you can see it. When you open up the door, you need to be able to see that again. You need to see that enclosure again. Open and close, you need to be able to see the warning symbols. And then on each of the fiber optic panels, then you're going to need to see that little starburst, this little thing here on the panels to indicate that it is potentially carrying lasers. Now, when we first wrote the standard, we really just had one fiber core every now and again. We had one here, then one here, then one here. But with MPO, we're now starting to present 12 fibers or more in very close proximity, increasing the danger associated with this. Now, the other thing that comes off as a little bit unusual is dust caps, we call them in the industry. Dust caps are not there, according to mandatory standards, to protect the fibre from dust. Not its function. It is a mandatory requirement that you put the dust caps on because we do not want lasers coming out and getting people. So if we class 3B laser, if you're shooting a class 3B laser, it can come out and burn you outside, particularly if you've got multiple of them together. So the S009 says you must protect people by putting protective caps on the end of the fibre. It is not a nice to do, it is a mandatory safety requirement. Now we get to my favourite people, engineers. Engineers are allowed to step outside the bounds of the normal requirements. The standard allows you, not me, allows you as an engineer to address specific requirements outside the mandatory standard. Because you are deemed to be a subject matter expert and you know what you're doing. It's interesting. We had on earthing, we had a professor and a doctor arguing earthing, and we came up with a compromise after getting somebody else involved to address the effective earthing on a premises. And you as an engineer could take it on yourself and say, no, I think that's too great. I'm going to put 2.5 there, or I'm going to do something else. I'm not going to earth it. And as soon as you do that, the responsibility of making that decision is yours. I'll give you another example where you're allowed to make an engineer decision. We have specified the minimum conductor size for an underground voice grade cable or underground twist pair cable, multi-core from building to building to be 0.5. 0.5. There is a lot of stuff that's a lot cheaper at 0.4. That's fantastic. So 0.4, you could, as an engineer, decide that 0.4 millimeter cable is adequate. You're only going to be running voice over it. So what's the problem? The problem is that we've got one pair cable coming. So in the course of the life of that cable, it could be expected we run multiple one pair services down there. And each of those services can carry up to maybe 2 amps down each conductor, maybe 1.2 amps per conductor, but certainly might be carrying some reasonable, even at 750 milliamps, which is what Eliminator 1 specifies. That is 100 pair of cable, and each conductor in that carrying 750 milliamps, we may get heat rise. And if we get heat rise, that cable may not be operational. If we've got health and safety stuff hanging off that, we may have a problem. So when you're considering doing an engineered solution, you just got to be understand that you take on, the risk. And that's probably the reason why you have professional, indemnity insurance. Surely that's the reason. So you can do this stuff. Surely it won't affect your life too much. That may or may not be sarcasm as I break down. They are a valid method of doing this, guys. There is absolutely nothing we say. If you're prepared to take on the risk, you can do it. However, if I was running an engineering management firm or a consultancy firm, I would be very careful in implementing this, because what you've got when you implement a standard is you've got safeguards. Why did you do this? Because that's what the standard told me to do. I followed best industry practices. What you're doing with an engineered solution is you're saying, I'm going to ignore what I've been advised by subject matter experts that have this broad range of considerations, and I'm going to go off and do my own thing. So feel free to do it. I'm just saying to you, you need to be careful about what you're doing. I had an interesting conversation with an engineer about that 100 pair. And he just went, I can just discount or put this down, 0.4 won't be there, any of issues. I actually asked him how he's going to address heat rise, and then he went, oh, I had not even considered it. And then we had a discussion about some of the other things about interference and other things that could play a part. And he said, really hadn't considered it. So it's just something to keep in mind. We have got people that will insist on smaller gauge cable because it's cheaper. But at the end of the day, somebody's got to be responsible for safety. And if somebody's got to be responsible for safety, it's either going to be the person specifying it or the person putting it in. Now, my second lot of favourite people are cable providers. You are subject matter experts, people. And you have no options but to follow the standards. I am sure the coroner would be impressed by your ability to say, the rules don't apply to me, and this is the reason why, when something goes wrong. The only time we really see anything with communications cabling going wrong is when somebody's hurt or harmed, and there's an investigation, and we have a very clear set of rules about what's going on. Now, most of the contractors I speak to say ACMA is never going to come out and inspect us, and I think that's probably true. But the only time I know ACMA will come out and inspect you is somebody gets hurt. And then we're going to get occupational safety, we're going to get the electrical regulator, and we're going to get the coroner getting involved to discover it. Now, I love the contractors because they will say to me, I've been doing this for 20, 30 years, like me, and never had a problem with this. This is before we started putting a whole lot of new technologies out there. So we've got a new lot of technologies coming. We've got ES1, ES2, and ES3. We have got IoT devices going into places. We're connecting everything. We're connecting building management systems. We're connecting WAPs and cameras. We're putting sensors. We're putting actuators everywhere, all there along the way. Now, the other thing is, as a subject matter expert, you are required to put in a safety sign-off. It's called a TCA1 form for those who have never done one. That is a safety form that says, I have delivered this safety. I have followed all the rules of S008 and S009. You are obliged under your registration to provide a statement saying what you have delivered is safe. Now, for the consultants and end users in there, that's a handy bit of paper to have, because that's somebody who's doing the work making a claim that what they've done is safe. If you don't do it, if a contractor doesn't do it, then they're in breach of their registration requirements. So not only if there's a problem, they've got the problem to resolve, but the fact they're in breach. So of the breach of the registration requirements. So it's something to get your heads around, that it's probably good that you're going to do some revision on this somewhere along the way. The other thing I want to do is
just one thing on the TCA1 form is the importance of that is it's worth mentioning it in design documents as well, as a reinforcement, should we say, through the channel to the contractor, to put some form of line in there to say that this is a requirement and should be submitted with handover documents, etc.
Well, it is. They can actually put it on the end of their invoice if they choose to. And just about anybody I deal with saying, this is your safety sign-off. I'm all about risk mitigation, so we take on risk as a living, so I'm pretty aware of risk. But if I can get somebody to give me a bit of paper who's a subject matter expert, who's signed off and said they've done everything according to what the safety standard, I've got a defendable position. I go to court, they say, why did you think this was safe? And I say, I've got a bit of paper here from a subject matter expert that says it's safe. Now, that may not be good enough for me in some cases. As an example, with the laser safety audits I've done. I've probably audited about 150 sites and found zero compliant to laser safety labelling since I've been looking at those particular bits of kit. So it's just something that I would recommend to I'm recommending to end users and engineers and consultants to actually get a TC01 form. I'm recommending to contractors that testing is really good for you because testing means that you left it at a certain place and time, and you can say these are the outlets, only change will be picked up and changed in test results. Is a really good thing, but it is a safety requirement. We're dealing with a safety standard. I'm always amazed that people don't understand that S008 and S009 are safety standards. Any other safety standards, people will jump through hoops to make sure that they comply with. We have two mandatory safety standards that are picked up under the Telecommunications Act of '97, federal law, and it's basically to do with safety. You can't assign safety. And the other thing is, everybody assumes somebody else is competent in this, is what my observation is. Everybody believes that they understand, somebody else understands this, and they don't have to. Cablers believe you can't buy product that isn't compliant. People believe that somebody wouldn't sell a product if it wasn't compliant. We've got engineers and consultants specifying the wrong cable underground, as an example. So they'll specify a cable, this is requirements of S008 or S009 for underground cable, put it in, and they're putting it into their spec. So there is a need for everybody to actually have a look at what they're doing and understand this is a safety standard. Things change. So we have things that change. S008 and S009 have changed. We've got S008, S009 has now got these new energy sources in. We've got IoT hitting us. We've got a more heavily reliance on things being, safety and security related. Service availability is becoming more and more critical for businesses. You cannot function without your IT. You can't have your safety and security positions without IT. And the physical layer, fibre optic and communications cable, crystal pair, is that backbone that gives you this platform that everything rides on. Who would have thought that 2020 would be the year of generational change? Who would have thought that we're going to spend this year, just doing things a little bit different than we have in the past? We have a time frame, guys. We have a time frame to work with. We have a 24-month, 18-month to 24-month time frame to actually do things. We kept an overlap period to give us enough time to change safety standards. We've got to understand what we're dealing with. You need to understand what you're dealing with. You need to understand what energy sources go with what equipment. If you've got a PoE thing, then the S009 says PoE is going to be ES2, so you've got a defendable position. But somebody gives you a new bit of kit that is not Ethernet. One of the first questions you've got is what sort of energy source is that? So you've got to go to people, you run a bit of new technology, somebody comes up with a new building management system. You need to understand what energy source is that running. Is it ES1, ES2, and ES3? You've got to understand that we are dealing with some stuff that is hazardous. We've got to understand that if you are planning to put in ES3 generic cabling, so something with an RJ45 in that somebody can plug up to, then there are special obligations on that. And let me tell you, you won't find the cable easily. One of the pushbacks we had from the people who manufacture cable is, we won't manufacture this because there's not enough demand. And my view on that was, that's great, because I really wouldn't like seeing people suddenly come up with an idea there to use generic ES3 cabling as a norm. We do not want anybody to specify ES3 generic cabling as a cabling, because it's got to be separated from ES1 and ES2 because of its nature, and we can't use it for ES1 and ES2 services. So I've already seen somebody had a draft specification, said, I'll just go with the best, I'll call up ES3 cabling for everything. And I had to tell them that no, that would be bad, because you install the cable, you won't be able to use it for ES1 and ES2 services. You need to understand that you have to get a set of products and get these in your head as they're being compliant. Things like underground cable at 0.5. So if you look at an underground telephone cable now, it would need to be at least 0.5 millimeter. It would have to pass a water penetration test and have to be UV stabilized. Those are requirements of for underground cables. Fibre optic cables, we have this really good idea in the Australian marketplace. We have indoor-outdoor fibre, and people think that indoor-outdoor cables are fantastic. They can be used in both places. Indoor and outdoor is two different requirements. Underground is another requirement. So we've got some people who are selling indoor-outdoor cables. People are buying it. Some of it is allowed to go underground, and some of it's not, according to S008 and S009. And I find it interesting when I speak to some of the manufacturers about their indoor-outdoor cables to find out if it is approved for underground use. I have to tell them about the existence of S008. I'll say that again. I have to tell them about the existence of S008. So this is product available on the market that people are going out and buying. And if you want to have a look at this, is just an exercise. Have a look at your underground cabling suppliers and see if their stuff is actually passing that water penetration test and the UV stabilization. It's interesting. We've seen some big specs recently where they're only calling up for external cable. They're not talking for underground cable. So the fibre optic has to be external. External cabling, if it's in duct, doesn't have any more requirements than indoor cable. So it's just something you've got to get a head around. I'm going to talk to you about trusted advisors. These are the people that are going to give you good advice. They may not necessarily be a salesman. They may not necessarily be an engineer. These are people who are going to provide you good information. I like BICSI. I'm involved in standards, but I like BICSI because if I've got a question about fire stopping, I'll give them a call and I'll say what's going on here. And they've also got a ream of experts that will come out. Paul worked with me on the standards, so S008 and S009. He was an active member of that particular standard and helped us navigate through some difficult areas. The reason I say trusted advisors are good is that you carry the can. You cannot assign safety. If you are a subject matter expert, if you're a registered cabler, you are a subject matter expert. If you're an engineer or consultant, you are a subject matter expert. You can't just rely on somebody telling you that it's all okay. Because at some point, if the advice is wrong, they're not going to be in the held accountable, or as they will be held accountable maybe, but you certainly will be in the firing line. I would suggest it's a good time to, in that 18 months where you're reviewing the standard, to review your risk profile as well. That takes me to the end, guys. It's quite interesting talking to yourself for an hour. Any questions?
Well, you did very well, Murray. Thank you very much. Any questions? Yeah, there's one or two. There's one or two. I've been trying to bat some of them off and put some answers myself to them, but I have flagged some for your special attention. So, in no particular order, obviously ES3 drew a lot of attention. So, examples of ES3 generic cablings, or maybe that should be ES3 applications.
Yep, so RFTC and RFTV, which are remote power feeds for carriage services, they would be examples of cables that would fall under that ES3 classification. GFast is another example where it can fall within that ES3 area. So there is another standard called 62368.3, and those are some of the examples they have on that. Some of the ISDN services were into that area as well, but typically they're high voltage, low current, so they might qualify for that. So that's the technology that exists now. We just don't know what the technology is going to look like in 5 or 10 years' time. The other thing I can point out, which may be surprising, we have something that's ES2, so this is safe to touch. And it's pulse powered. It's called Volt Server, and it's a product being distributed in Australia by Prysmian. That's delivering 1,000 watts of power at a kilometre. 1,000 watts of a kilometre over single pair communications cable. That's using pulse power, and had it not been that pulse power had been straight DC, that would be ES2. But we certainly can touch it. But basically, it sends out pulses of power and then it does detects any decay in that power, and if there's decay, it indicates there's a problem, so they'll shut it off. So that product's available. That is ES2, but somebody could take that same technology without the safeguards and market it, and S008 and S009 couldn't stop it.
Thank you. Continue on the ES3 thread. Surely ES3 has no RCD protection for earth fault detection.
Are you talking about the? This is not electrical. This is comms. This is not electrical. So most of electrical, it may be tied to earth, but typically PoE is not tied to earth. Yeah, it could be floating. So it can be dangerous. ES3 is important to note. We've had LV telecommunications for some time. So this is, as I said at the beginning of the slides, this is not new. This is a small way of getting to think about things. So PA cables would be application specific. We had to address ES3 generic cabling because that would be people running remote power feed for VDSL services, RFTC and RFTV circuits in something like a mining site. We need to address it. It is no way known that I would support anybody using it other than those particular applications. And I think there are versions of RFTV and RFTC that would make ES2. And I know NBN's working on that at the moment in some of their deployments, and they're trying to get it down to ES1 on those circuits. But those are examples I given. I would hate to see anybody bring a product to market that is ES3.
Continuing on, I'll tell you when we're not asking questions about ES3. Is it root mean square RMS or peak power? Are there differences for DC and AC applications?
No, it's this is basically, it has a voltage. If you look at this, it's basically, there's a voltage limit, so you can have any volt. All three of them, ES1 can have any voltage you like. You can have 1,000 volts, you can have 2,000 volts, you can have 3,000 volts. Doesn't matter to ES1, 2, or 3, as long as you've got current limits. And then if you've got a current limit circuit, then you have any voltage. But if you have a voltage limit circuit, then you can have any current you like. And that becomes interesting because then you start getting problems with heat rising cable.
Okay, regarding labeling.
Can I just go back? I think what they're asking is electrical regulation kicks in over certain voltages. I think that may be the question they're asking. And the electrical regulation, my understanding, I'm a telegraph mechanic, not an engineer, and I'm not a Sparky, but my understanding is that the electrical regulations are based on AC and steady state DC. There is nothing in there about pulse power. So pulse power at this stage is outside of regulation.
Okay, I've just looked it up. I've got the latest S009 here. Damien, that's covered. Well, the only mention of RMS in S009 is F.34, which is the ES3 special application cabling. It's the only time RMS is mentioned up to 100 volts AC specifically. Let me just see to make sure I've covered off all these ones. There we go. This is the recommendation for ES3 installs external use in mining environments of PoE. Would it be recommended using a foil shielded and grounded Cat6 generic cable of minimum 0.5 mil? That's a very specific question there. So that's
if you're on a mining site and you're using ES3, I think you've got the wrong application. The ES3 is hazardous, and it would spark. I don't know if you would get anything. The only place, depending on what you're using it for, the only thing that you would use it for would be remote powering feed to feed a D-slam or something like that. So if that's the question you're asking, I see. I'd be curious of why the conductor size would be the big thing. What's your conductor size? The bigger the conductor, the better. So you would put in 20, 23, 22 AWG. 0.6 and up millimeter cable to get that reduction. We get into debate about shielded and unshielded cable, which will set us off to a major debate. The difference between shielded and unshielded cable, if you apply 4763-2, is about 1 degree. So there is some difference. I don't even remember which way around it is. Makes a beautiful discussion about what's going on, why you would want to do it. You know, about shielding versus unshielded. The problem with the shielded cables, they're earthed, and lightning strikes are an issue. And on long runs, they would also form earth loops, and you get earth difference between earths at both ends of the cable if you earth both ends. So there's pros and cons for it. We've not actually addressed that in S009 as a requirement, but there's benefits for shielded and unshielded cable in that deployment as well as anything else. I hope that answers that question.
Yes, I think it does, mate. Thank you. I'm just going to change the topic away from ES3 now, actually. Regards laser stickers, would I be required to retrofit stickers to all equipment if I only work on one specific piece of equipment?
I can't. I just need to be a little bit careful how I answer that. The standard doesn't talk about it. However, under my duty of care, I would look at this as a duty of care. If I'm working on a particular cabinet, me personally, I would bring that cabinet up to speed because I worked on the cabling in that particular cabinet. I would bring that cabinet up to regulation, putting 2 stickers on the outside, a regulatory notice and a information notice and a starburst. Open up the cabinet, I'll put another one on there, and then I put a little starburst against the panels that will be inside. Then I would write a nice letter or an email to the people saying, are you aware that these labels are labelled in accordance with a mandatory safety standard, and transfer the duty of care from them, from yourself to them. So you don't have to fix it, you just got to tell somebody about it to fix it. You might score some other work. There's also a TCA2 form which you can put in indicating that somebody's not done the right thing. But typically, if I'm working on a cabinet, I would bring it up to speed. Just about everything I do with my duty of care in mind, I would just transfer the risk. So it's just an email saying, under my duty of care, I point this out to you. As long as you've done that to somebody in the organisation of authority, you're pretty well, in my mind, addressed your duty of care.
Okay, thank you. There was one other question. I'm just a bit wary of the time. We're at 12 minutes past now. It's regarding the testing. There's 2 testing questions, actually. One is the testing of field termination, so the modular plug terminated link. The second one is actually to do with single pair Ethernet.
Yep.
And the testing of that.
Oh, the testing of it. To be advised is on that particular one. I know Fluke are working on a test at the moment. There's a standards meeting later in September where we'll get some progress on it. There will need to be a test standard coming up for that. That will be, and things like alien crosstalk will become more interesting for us with 1-pair systems, because obviously when we've got a 4-pair system, we test for crosstalk inside the cable. On 1-pair systems, you'll have multiple pairs running side by side in different cables, so that would be alien crosstalk. So the testing would have to address some of that along the way. So I don't think it's an easy question to ask. I'm not aware of where that's progressed other than there's been work done on it. On modular plug terminated links, the test method is defined in 11801-1. Australia and New Zealand have a standard for testing modular plug terminated links, partly because of this fitness for purpose. People were asked to install cabling and make sure it was fit for purpose. They had no test method for it. So 11801 put that up as a test method. So we're one of the few countries in the world that has it. And my company actually sponsored the New Zealand version because I didn't know how New Zealand people were going to address their duty of care, and I do work in New Zealand. It sounds like I did something quite generous to them, but all I did was save myself a hell of work because I didn't know how else to do it. So both the Australian and New Zealand test standard, 11801 has a test standard contained in 11801. Basically, it's a permanent link adapter on one end and a patch cord test head at the other. I just happen to have some here. Make sure I've got one. These are the 2 things I'm talking about. This is a channel adapter. This is one you buy and you get with your kit. It looks like that. This is a patch cord test adapter. They look very similar. except this one's got a very expensive plug in there and this one doesn't. You need to have one of these to actually test. Without one of these, you are not compliant to the standard. It's not commonly known, but channels, the plug on the end of a channel, the plug that plugs into the device at the end of the channel at both ends isn't covered by the channel. So typically if you test a channel, those plugs aren't tested. The difference between a modular plug terminated link test and a channel test is a modular plug terminated link test will test the plug that you have put on the end of the cable. There are vendors who will sell you a plug that can be terminated on cables. We have other people that will sell you a pre-terminated cord that you put into a CP or through an adapter to get there, or others that put a patch panel in the ceiling and use long patch cables to create modular plug terminated links. They're all available. Yet again, you cannot put this in arm's reach of people. So if you think you can just bring a cable down the wall, punch it through a hole and clip on the plug, that is illegal. It says so in S009. It's got to be out of arm's reach or secured. Now, we're very clear on that. The exemption for patch cable, so typically putting a patch cable in would be classed as cabling work. There is exemption to allow customers to put in a patch cord. There is no exemption for them to put in fixed cabling. So the people that would end up doing that would also be breaking the cabling rules. So again, wouldn't qualify as being fit for purpose, wouldn't qualify for meeting S009.
Now, just as important as our fantastic audience here today getting educated, a couple of questions have come in from trainers asking when the training package from the ACMA effectively will be available to RTOs with all the new information in.
I don't know. I didn't think that. Look, I'm not in that space, but I didn't think. I thought that was handled by somebody else besides ACMA. I know ACMA's put out some information regarding their questions recently as to what questions they, how you need to address questions, how you need.
Just haven't seen that email yet, Murray. I reckon that's waiting in your inbox. Could you dream up the question bank for that? I don't know. Okay, so that's not something you're aware of. That's fair enough.
Okay.
Let me just have a look. I think for the bulk of the questions, some of these are quite specific. What I'd say to the 285 people that are still here right now, thank you very much. I would say a lot of the questions that have been asked, and I've kind of glossed over some of them, can be answered with the new S009 itself. So I understand you might have some very, very specific questions that need a definite answer, but I would say looking at some of the questions on here, they are and can be answered within the new S009 document.
Look, I think too, just to note that Paul sat on the standards, and I'm sure he would like to take any questions about ES1, ES2, and ES3.
I'm sure he would, absolutely. And Paul's going to come back on in a moment, and I'm sure volunteer is time for that.
I've got a bottle of gin bet with Paul that he's going to get inundated about questions about ES1, ES2, and ES3. So I'm just trying to promote the fact that everybody calls him and asks at least one question about ES1, ES2, and ES3. So I get a bottle of gin.
Well, I think on that note, we might just call Paul back on, please.
I'm back here. I am a little bit nervous about this bottle of gin. Hopefully it's only a single, not many. I'm already conceding defeat on that, Murray.
Excellent. That's all I need to hear. That's a good way of getting out a whole lot of questions about ES1, ES2, and ES3. Well, probably one of the things I want to close about, LV telecommunication cabling has been around a long time. The fact we're calling it not LV telecommunications, we're now calling ES3 application-specific cabling. There's no change. It's a change in name only. The one that you should be concerned about is ES3 generic cabling. No one's selling cabling product in that area. No one's promoting it. The only time that it will catch you out is if you start mucking around with some of the remote power, long-haul remote powering that you would be done for DSLAMs or the like from some of the technologies like VDSL or GFAST. So, but again, it's worthwhile asking the question of your suppliers what the energy sources on that. I would be disappointed to see us move into a market where we were using ES3 generic cabling. And can I just say again, for goodness sake, do not specify ES3 generic cabling as a default position. It is just fundamentally flawed and add great expense, great complexity, and you won't be able to use it for ES1 and 2 services.
Okay, Paul, if you'd just like to take a minute or so, just wrap it up, please.
Sure. Look, I'll just provide a few concluding comments. Mostly all thanks. Certainly thank you to Murray Teale for articulating that very important information to us. Murray, as you pointed out, I'm on the committee as well. We've spent about 2 years working on this. It's not about trying to re-engineer the regulations and specifications. It's about dealing with the trends in technology and applications to make sure that the infrastructure delivers what it's supposed to do, fit for purpose, and really to cover us professionally and from a safety point of view. So these are very important. What we haven't seen is the many, many hours that Murray has invested in recent weeks to try and condense so much information into 1 hour. So we seriously thank you very much for that, Murray. Really appreciate that. Also want to thank Craig and R&M for facilitating this platform. Craig, you mentioned 288 we had at one stage. I noted there were about 327 people on the initial presentation during the course of Murray's presentation. Obviously, some have dropped off. As big a number as that is, I certainly believe we should have 100 times that number because the industry is very large. We've got a lot of, there are tens of thousands of cablers. There are hundreds, if not thousands, of engineers who are involved in this side of things across Australia, New Zealand, and other parts of the world. The more people know about this and apply it, the better we are. And really that becomes the motivation for BICSI to run these webinars, to contribute to the professionalism of our industry, certainly so that we do provide a better service and get a better reputation amongst the community. But secondly, and equally important, to protect us, both commercially and from a safety perspective. We need to make sure that we are covered, that we're not taking risks. And basically part of the service is to help people understand what the risks are and how to mitigate these risks. And this is where, secondly, I'd like to sort of thank the other registrars who promoted this to their cablers. This is not specific to just BICSI or BRCA. This applies across the industry, across all registrars. And for you cablers who've attended, in fact, for everybody who's attended, consulting engineers, end users, suppliers, cablers, this is an investment, a very small investment of an hour of your time. I'm sure that the dividends it pays is manyfold because it helps you to understand more about the regulations, the changes that are going to happen, and also where to go to for more information. Clearly, we can't answer everything all in one hit, but the important thing is to give you some direction as to where to go to, who to go to. As Murray pointed out, he'll be taking questions. Unfortunately, I'll be taking questions too. I've got a bottle of gin running on it, haven't I, Murray?
You have indeed.
But in fact, look, can I actually suggest your very first action, and just literally straight after we get off this webinar, please go to comsalliance.com.au, put into their search box S008 or S009 or both, download the documents, the 2020 documents. They're only a few weeks old now. I think S009 is about 250 odd pages. S008 is for supplies, it's product. It's about 70 pages. Download it. It's a PDF. They're both PDF documents. Importantly, you don't have to read it from cover to cover, but be aware of the search function, and that's the beauty of PDF. If you've got questions on issues, if you want to do some drill down onto ES3, just type in ES3 and you'll find lots and lots of information. It's a living document. Sorry, it's not a living document. It's been published, but utilize it progressively. You'll be using it for quite a few years, so it's quite important.
And it's free.
And it's free. Thank you, Murray. That's the most important thing. Isn't it nice that regulatory documents are freely available and we encourage everyone to get access to it? So do that, please. Do yourself a favor, and that's the most important thing. The topic of training was raised up a little earlier. There are a number of organizations who are looking at this thing, people who are affiliated with ASQA, the Australian Skills and Qualifications Authority, who sets the tone for all vocational training. They are looking at this topic. There has been a review of telecommunications training under PricewaterhouseCoopers. They did that review some time ago. There are new programs out and will be delivered. So the training fraternity, the RTOs, are currently updating their programs. We are in communique with many of the training companies, as are the other registrars, in particularly TITAB, the Telecommunications Industry Training Advisory Board. The name alone says that they are specifically connected to the RTOs. I know some of you RTOs are on this webinar at the moment as well. There is going to be a considerable amount of communique going out to industry and to RTOs collectively through the registrars to make sure that everyone's aware of the changes, what's important, and to encourage people to look at it more. So with that, I'll close and thank you all for your participation. Once again, I'm convinced this investment of an hour of your time is a very wise investment, and hopefully it will give you an appetite for more information. And by all means, as we said, the places to go to, comsalliance.com.au for the documents, contact Murray or myself for more information, and we expect to hear a fair bit from you, and we hope to articulate more information on these important changes. So thank you all once again for your participation.
Excellent, right, well that's it. Thank you very much everyone. That's a great 1.5 hour session we've had there. An absolute outpouring of thanks on the questions tab coming in. So thank you very much everyone for attendance. Of course, thanks very much to Murray for doing the presentation. Never be shy to ask the questions. I'll put the links up there for you can go and grab the new S008 and 9 at your leisure. If not, just Google a good search and you'll find it. And as Paul said right back at the start, this will be available probably at the start of next week by the time we've done everything with it via the BICSI website. But if you've got any questions, please feel free to ask. At this point, I think we'll close it. So thank you very much, Murray. Thank you, Paul.
Thank you.
Enjoy the rest of your day. Goodbye.